Today about classifying triangles by their sides and by their angles. What we're going to do is we're going to just talk about the different ways we can do that, and then I'm going to show you how to use that to solve with some math. So the very first way we can classify a triangle is by its sides. If we have three sides that measure exactly the same, it's called equilateral. All three sides measure the same. So if you know that this side measures 8, guess what this side measures?
80.
8, and this one measures 8. All of them would have the exact same measure. When that happens, it's called what?
Equilateral.
Equilateral, thank you. Okay. The second way we classify a triangle by its sides is called isosceles, an isosceles triangle.
Hey, you were right, Will.
Yeah, an isosceles triangle has two congruent sides. So here and here. These sides are usually called legs, and the angles that are formed at the legs would be called base angles. Okay? The rules that we know about an isosceles triangle is that these two legs would be congruent. They're equal to each other, which also makes these two base angles congruent to each other. Okay? So in an isosceles triangle, the two sides are congruent and the two angles are congruent. Okay? The next one is called scalene. When we have a scalene triangle, it's when we don't have any sides that are congruent. So all three sides measure different measures.
You can almost make that a parallelogram. I think that's what it's called.
All right, classification by the angles then. You guys actually listed acute as a triangle that you've heard of before on the bell work. Can anybody tell me what acute means?
Small.
Small, okay. How small?
Smaller than 90 degrees.
Smaller than 90 degrees. That's exactly the definition of acute, is less than 90 degrees, which means all three angles have to be less than 90 degrees. Okay? Equiangular means all three angles are equal. If all three angles are equal, we can actually know what those three angles measure. There's 180 degrees in a triangle, and it has to be split 3 equal ways. So what do these angles measure in an equiangular triangle? Do 180 split 3 even ways?
180 divided by 3. 60.
Yep, you're right. 60 degrees, and 60 degrees. They add to 180, and they're equal to each other. That's an equiangular. And then, if it's equiangular, do you notice also that it's going to automatically be equilateral? So equiangular automatically becomes equilateral. Okay? All right, the next kind of triangle that we classify by its side or by its angles is a right triangle. A right triangle means it has one right angle. What does a right angle measure?
70.
Ooh, that's close. 90. It means it has one 90-degree angle in it, which automatically means the other two have to be acute because of that one 90-degree angle. And then obtuse means that you have one angle that measures how much? Yeah, greater than 90. So you have one angle greater than 90 degrees. Okay? So those are the ways that we classify triangles, by their sides or by their angles. So what we're going to do now is we're going to look at some triangles. We're going to decide how to classify them by their sides and by their angles. So we should be putting 2 different answers on each one of these. And then we're going to use some math to solve for missing parts. So looking at the sides, what do you know about the sides of that triangle? They're equal. So the name for a triangle with 3 congruent sides would be equilateral. So you're going to classify this triangle as an equilateral. And then you also have to classify it by its angles. So noticing the angles, all three angles are equal. So how do you classify it by its angles? Yep, equiangular. Nice job. Okay, so again, we look at the sides and give it a name. We look at the angles and we give it a name.
What is that word even? Equal angle.
Yeah, equiangular.
What the fuck?
Okay, look at the next one then. Let's do the sides first. 13.2, 11.2, and 7. All three sides are different. So go find your name for a triangle that has all three sides that are different. So up here on the sides.
No congruent. Oh wait, scalene?
Yeah, it's scalene. Nice job. Then we're going to look at the angles. We have a 58-degree angle, a 90-degree angle, and a 32-degree angle. So classify it by its angles now.
Right.
It is right. Nice. Okay, it's right because it has one 90-degree angle right there. Okay, next one. Look at the sides first. 2.5, 2.5, 4.5.
Which one has two that are the same?
Oh, isosceles.
Yep, isosceles.
Gosh damn it, I want it to be obtuse so bad. Come on, man.
So isosceles for the sides. Now look at the angles.
Obtuse.
Good job. Obtuse.
It is. It is an isosceles obtuse triangle. Okay, last one that we're classifying. The sides here, 7.4, 6.1, and 8.7. So no congruent sides. We call that scalene. Then we look at the angles, 44, 79, and 57. Acute, nice. Okay, all of them are less than 90 degrees, so they're acute. All right, so what we're going to do now is we're going to use that information to solve for missing parts of the triangle. So right here, I have an isosceles triangle. Do you guys agree with me? Two sides are marked congruent. And I told you if the two sides are marked congruent, what do we know about their base angles?
Good job,
They're the
Jasmine.
same.
I heard Jasmine say
So
that.
what does angle Y have to be? It also has to be 52 degrees. Okay? Now if I know that those two are 52 degrees and I need to find the third angle, what do I know that all three angles add up to be? 180, good. So do 180 and minus both 52 angles off of it. When you do that, you get 76. So you know that top angle has to be equal to 76. So now we're just going to solve that equation. How do I get the x by itself? I need to move the 6. How do I move the 6? I do. Nice job. So I subtract the 6 over and I get 14x equals 70. How do I get rid of the 14? Very nice. Divide by 14. And what do you get x equal to? Yeah, 70 divided by 14, which is also 5. So my x value is 5. So do you guys see how knowing that this was an isosceles triangle helped me find the missing measures that I had? Okay. So this next one right here, also an isosceles triangle. Do you see how the sides are marked equal? So what do you know about the sides of an isosceles triangle? The two sides that are marked the same are equal. So do I need to use this x minus 4 at all right here to solve for the value of x? I don't. It's like extra information right now, right? So I get to do 2x minus 1 equals x plus 7. And I get to solve this equation for x. Now, I always tell you to isolate the variables first, meaning move the variables together on one side. I like to keep them positive, so I'm going to subtract the x over to the other side. So 2 minus 1 is 1. So I have 1x. I'm bringing down that minus 1, and I'm rewriting the equal to 7. Now, how do I get x by itself? Yeah, add 1. So what's my x value? Good. Okay. Now it said to find the missing variable, so I actually did. My variable is x equals 8. But could you find the length of these sides if you wanted to by substituting that 8 back in? You totally could, right? What would this side measure right here? 8 minus 4, which is 4. This would be 8 plus 7, which is 15. And this would be 2 times 8, which is 16. 16 minus 1 is 15. You see how easy that was to check my work? I knew those had to be equal to each other. So substituting it in to make sure that that worked is always a good idea. All right, last one here. They gave me the 40-degree angle. And I'm assuming they want me to find these other two angles down here, because they didn't give me any information about the sides. So this is an isosceles triangle. What do I know about the base angles of an isosceles triangle? They're the same. So I know all three of them had to add up to 180, which means I have 140 degrees left for this one plus this one. Yep. So this has to be 70, and this has to be 70. Okay.